This is the notes for 1.2b, functions and relations. Okay, to start off with, we know that f of x equals y. That is your standard form. So if we look at question 1, it tells us that f of 2 equals something. That's what they're wanting us to find. Okay, so what they're essentially telling us is that we know that our x value is 2. What is our y value? So on our graph, all we do is we go to where our x value is 2, and then we go either up or down to our graph. In this case, we're going down, and then we read our y value. So in this case, f of 2 would equal negative 2. Okay, question 2 is similar. They're asking us two things in this case. So again, our base form is f of x equals y is what we're going to be using. So in the first case, they say f of x equals 3. So they're telling us that our y value is 3. They want to know what our x value is. So in this case, we go on our x-axis to 3, or rather our y is 3, they want our x, so we go on our y-axis up to 3, and then we either go left or right to find where our graph is at. So in this case, we actually have points on both sides. So one of our x values would be at 2, and our other x value would be at negative 1. So we would actually have two answers here if we wanted to put both of them. The second part says find f of 1. Okay, again, this is telling us our x value equals 1. What is our y value? So at this point, we go over to our x-axis, so the value of 1, and then we either go up or down to our graph, but in this case it actually lands right on the graph. Therefore, we know that f of 1 equals 0. Okay, question 2, or 4 rather, asks us to find the domain and range given a set of points. Okay, so this one's actually pretty simple. Domain is your x values. So in this case, all we do is we list our x values. And so we have 4, negative 4, 0, and negative 4 again. So 4, negative 4, and 0. Okay, even though negative 4 is here 2 times, we only list it once. Range is our y values. Okay, so in this case, we have y's of negative 7, negative 1, 4, and 9. So negative 7, negative 1, 4, and finally 9. So as you see, your domain and range do not have to be the same size. Okay, question 4 gives you a set of relations and it asks you whether or not it's a function. Okay, so in this case, you know that your domain, which is your x values, can only go to one range, which is your y values. So if you're dealing with a set of points, the easiest thing to do is just look at your x's, and if they're all different, then it's obviously a function. So here we have x values of 0, 6, 4, and negative 3. Since these are all different, this is a function. If we look at our second relation, 2, -4, -9, 7, again, all different, so that would be a function. An example of what would not be a function is if you had, say, the points 2, 5, 3, 8, and 2, 6. Okay, so this one, if we look, we'd have x of 2, 3, 2. Okay, so we have the 2 showing up twice, once going to 5, once going to 6. This would be an example of not a function. Okay, in the next example, they're showing you a chart with your domains on the left, your ranges on the y. Okay, so again, your domain can only go to one range. So the easiest way to do this is look at your arrows. If your domain has more than one arrow coming off it, as this one does here, then it is not a function. If each one of your domains only has one arrow coming off of it, then it is a function. Right? And as you can see, it doesn't matter where they're going, if they're all going to the same one or whatever, as long as each domain only is going one place or has one arrow going off of it, you know it is a function. Okay, finally, question 5 deals with telling if a graph is a function or not. For this, you're going to use the vertical line test. What the vertical line test states is that if you can draw a vertical line and hit the graph in more than one place, then it is not a function. Okay, so if we look at graph 1, notice that if I were to draw a line right here, I'm going to hit it 1, 2 spots. Therefore, this one is not a function. Same idea here. Basically, if I draw almost anywhere, I'm going to hit it 1, 2 spots, so not a function. If I look at graph 3, notice that wherever I decide to draw my line, I'm only going to hit my graph in one spot. Since I'm only going to hit the graph in one spot, this one is a function. Okay, graph 4 is a bit of a trick. A lot of you will look at this and think, oh, okay, well, if I can draw my line here, I'm going to hit it 2 spots. Okay, that's not the case. Notice that this dot here is an open circle. When it is an open circle, that means that point's not really there. That's telling me that this line here comes up to this point, but doesn't actually reach it. So even though this line here hits here and here, this point's not really here, so nowhere else would it hit 2 spots, therefore this one is a function. Okay, graph 5. Again, basically anywhere I see a dot, I kind of try drawing lines, see if any line would hit more than one dot. Okay, and what I'm seeing is that basically that's not happening, therefore this one would be a function. And then lastly here, again, hitting 1, 2 spots, so not a function. So that was the notes for 1.2b, functions and relations.